And I think, how do I say his name again? Is Michael online? Michael Gary?
Yeah, I'm online.
You emailed me something regarding GroupMe. Did you want to tell that to the class?
Yeah, I just shared it in the chat, just so everyone knows. I create the group me is in the chat.
But you want to describe it about to him, so.
Oh yeah, group me is just a pretty much a group message board, so that if anyone has any problems or working it out, you can get on there and chat back and forth with each other.
And I'll put it on the announcement page for people who, if they lose the link, I'll post it on the announcement page.
Okay, awesome. Thank you.
GroupMe. And submit. You should see it now if you log in, log back out. So let me share my screen. Share screen. Share application. All right. Let me know if you can start seeing my screen. Yes, I think you can now because I kind of see it. Got in a late start, but today is the 31st. I usually have the stuff written on the board. 31st, up, 31st. So we're going to review Chapter 1 and go over Chapter 2. We won't have an in-lab. We'll have an in-lab on Wednesday. But just a reminder, a week from today, woohoo, 3-day weekend for those people that get to enjoy it. We're not going to be here on Monday, but let you know, we will have our first quiz on Wednesday when you come back. It'll cover chapters 1 and 2, and it will be on Blackboard Online. And I'll show you where to go in a minute. But for right now, let's review chapters 1. Usually during the review, we were in class, so I would have students come up to the board and answer questions and so forth. But since we don't, I'm going to try it this way, and you can tell me how it is. I want everyone to put their notes away and see how much you can do. Some of these questions that I pull off the actual hard copy of the book, I do not see the on the Paravel website when they give you the online book, they don't have the end of the chapter review questions. So please pay attention to some of the questions I ask during the review, because sometimes I have put the similar questions on the quiz. Usually before it was online, I always had my quizzes paper copy because I wanted to see how much students know, and I would block off the computer. But since we're online, I cannot really do that. But let's see how well you guys know. Can you see everything clearly? It says Chapter 1 Review.
Yes.
All right.
I can see it.
Thank you. Since I can't hear the message dings or I can't see the charts, so just scream out the answers. But I do not want you to have your notes or book open. I want to see how much you can review, how much you can remember. Steps from source code to executable. What are they? What is the first step?
Wait, what was the question again?
The question was, well, you have the source code to the executable file. When you do that compile on it, we talked about the flow on how it progresses through.
Doesn't it go through
the preprocessor?
So the first step is what? Read the question. Step from source code to executable. So what's the first step?
Create source code.
Source code. What's the next one?
The preprocessor.
put it through the compile? I mean,
Preprocessor. So preprocessor. The third one? It starts with an M. You got the source code, then the preprocessor executes and garbage up the source code. What kind of?
Modify.
So what's on step 3? Did I lose everyone?
No.
No, we're still here. I think everybody's quiet.
Modified source code. What's step 4? Oops, I gave you that one, compiler. What's step 5?
The
Remember, once we go over it, you're responsible to know it.
Object.
Step 5, object code.
Okay.
The compile code gives you object code. The object code has everything but the system libraries in it. What's step 6?
linker.
Linker. Last one?
Executable code.
There you go. Everyone should at least got the first one and the last one. Each byte in memory is identified by a unique number known as an, starts with an A,
An address?
address. Very good. A program is a set of blank that the computer follows to perform a task.
Instructions.
Instructions. Very good. Blank is a set of well-defined steps.
program.
Algorithm.
No. Someone said algorithm. That's correct. A
Oh.
blank defines all the tools needed to write, compile, and debug a program into a single software application.
IDE.
IDE. Very good. Keywords, also known as blank, has special meanings in C++ and cannot be used for any other purpose.
Reserved words.
Reserved words. 3 steps that a program typically performs.
Gathers, processes, and outputs data.
Yeah, very good. And then also I had this one. I did a PowerPoint slides of the word. These were some of the ones that were in Chapter 8 review questions. I don't know if they're, I didn't see them on Parallel side, but some of these are good. Both main memory and secondary storage are types of memory. What's the difference between the two? Anyone can.
Main memory is typically RAM, which once you turn off the computer, it goes away, and secondary storage stays even after when you turn off the computer.
Very good. What is the difference between system software and application software?
The system software, it runs the things like your OS, while application software runs the apps on your computer.
Kind of, the system software manages the hardware.
Okay.
The application is what we use as in like user applications, such as Word, gaming systems. But close, good job. What types of software controls the internal operations of the computer hardware?
System software?
What type? It's operating system. But yeah, system software is a type of system software. But what type of software controls? It's the operating system. That's the answer. But operating system is a type of system software. Why must programs written in high-level languages be translated into machine language before they can be run?
So the computer can understand it?
Yes. They're written in a high level so us can understand what we wanted to do, but yes, it needs to be compiled. Explain the difference between object file and executable file. I just mentioned this a moment ago.
Isn't object file is before it's linked, goes through a linker to make it an executable file?
Object file is the machine code that's compiled but doesn't have any of all the system libraries needed to run. The linker, when it creates executable file, the executable file has those system files. So think of the object file does not have the system files, and the linker links it and creates the executable so it has access to it. So that's the difference. One has the system files, the other one doesn't. What is the difference between a syntax and logical error? This is going to be getting on a little bit further down, but remember we talked about, go ahead, someone's speaking up.
Sorry, a logical error is if it's not technically like an error with it's an error with your code with the way you wrote it. So like it'll still run, but it's not performing the way you think it should. Whereas the syntax error is like you wrote something wrong.
And the compiler catches it.
Yeah.
Yes, very good, very good. What words that have special meaning in the programming language are? We just mentioned this a moment ago.
Keywords.
Keywords or reserved words, I always accept either. What are oh, I mistyped that. What names defined by the program?
Variables.
They actually had programmer-defined identifiers, but it is variables. You're correct. So how do you feel now if these questions were on a quiz?
That'd feel good because we reviewed them.
Very good. But if we didn't have this review, how would you have felt if you would have saw these questions?
Kind of different.
So do you like these kind of reviews to help reinforce some of the things you should have picked up in that chapter? Yes or no?
Yes.
Yes.
It helps to. I think for me, it helps to make sure that whatever, like, if I'm studying by myself, it helps to make sure that I'm studying the right material.
Okay, good. All right, let's go ahead and get started with chapter 2. This is going to get a little bit more in depth as we step through it. And if need be, I can open up Visual Studio and we can go in more depth to discuss this. Let me see if I have F5. Why does this not? Slideshow. Let me start. Can everyone see it clearly? Okay. Now we're going into the part of the C++ program. If anyone has questions, do not click the bell to raise your hand. Hold on, before I get started, did I do hit record? Yeah, it's recording. I cannot hear you guys ding to raise your hand, so if you have any questions on the slide, just speak up.
All right.
The parts of a C++, go ahead, someone. Okay. The parts of a C++ program. In this example, which we just did last class period, we just displayed something simple to the screen. Here's parts of the program right here, and we're going to break these apart through each chapter that we go. In this chapter, we're going to cover cout and variables. The next chapter, cin. Chapter 3, we're going to cover cin. So it's going to break each one in each chapter. This right here, these forward slashes right here, is what we call, in this syntax, there's a multi-line comment, but this is a single-line comment. The comments are used for helping for debugging purposes. If you want to block out code that the compiler doesn't want to see, you can use it for documenting purposes, like for a particular bug that you're fixing, you want to document in the code what you're fixing. All kinds of reasons. You can insult another developer in your comments. The end user does not see the comments. The compiler ignores them, but they are checked in to wherever you check in your code. So other people that have access to the code will see it, but it's used for documenting purposes, debugging purposes, whatever you want to think for comments can be used for. But the compiler simply ignores it. When you see me look at your code and I can't see the syntax right off the bat, sometimes I just start commenting out code until my eyes focus on where I need to go.
Hey, actually, I had a question.
Yes?
Isn't the when you're declaring your function, which in this case it's main, isn't the word before main, isn't that like the return value?
Yes, that's what I was about to go to. But yes, you're
All
correct.
right. Bye-bye.
The pound include is a preprocessor directive. You include those in to use certain functionalities in your code, like we saw before when you did the cout. And same thing when you talked about this before, the using namespace. These in conjunction allow you to use cout without using the std : scope resolution operator. This sends information to the screen. Just like the gentleman said, sorry, I'm still learning your names, so plus it's harder because I can't see anyone. This is a function that when your program executes, the calling of your program looks for main and then starts executing from that point. You never call main. Never, never. But this is a function call. Oops, I accidentally hit my mouse. This, can I do this?
We can see your mouse. I mean, your.
I know. I'm trying to see who this be. Right here, this int main right here is saying it's going to return an integer type. Here's the driver function, and here's the closing and ending of the main functions. Notice how things are indented. It doesn't have to be indented, but it helps for clarity. But any questions on the parts of the program right here? Okay. Some special characters. The forward slash right here are the double slashes are to begin the comment. This you would see when you need the preprocessor directive. We saw that with the iOS stream, and you might see them sometimes with the old C style when you do a pound define. These angle brackets are used for the iOS processor right here. Preprocessor. If you're using your a standard library that you created, you won't use those angle brackets. These closing open close parentheses right here are used for the functions. The curly braces, I call them curly cues, are used to group blocks of code, such as in the function. Open quotation marks for string literals, and each statement ends with a semicolon. The cout object, you have seen it. Notice it's an object. If you open up your Visual Studio and you do cout dot, you see a whole bunch of other member functions that you can use. So it is an object. Displays the output on the computer screen. Use the stream insert operators, that's the left side, those less than, to send it out. What you see is what you get is right here. This is what's going to be displayed to the screen. That it will show on 2 lines on the screen. Is that clear? So when you read these things, it's going to be literal, what you see. Hello, space, there. And even on this one, you would say hello, space. There's no formatting right here, but I still have it on the cout, so it's still going to be on the same line. Here's just an example right here. 2 cout statements, but it only forms one single output on the monitor. If you want to make it go to a second line, you will use this endl. This is not 1, this is a lowercase n. I'm sorry, a lowercase l. Programming is, pretend like you hit the enter key, and like in Word, it goes down to the next line. So fun. Programming is, next line, fun. Any questions on that? That's the way we're starting to format our output. And here's just what it looks like on the screen. And I just repeated this. It's the lowercase l, not the number 1. Notice also, I forgot to mention, that it is outside the double quotes. If you put this inside the double quotes, it would say programming is endl, and then the same line fun. So be careful. This is on outside the double quotes. You will see other escape sequences, and that's followed by a backslash. A backslash means the next character is interpreted. It means something. It doesn't necessarily mean backslash n. In this case, it does the same thing as the endl line. It's just inside the double quotes, and you have this new way of doing it using backslash n. Same thing, you have backslash t for a tab, backslash a for the bell alert. There's a list that you can find in your book and online of all the escape sequences. This is what we call an escape sequencer because the backslash right here and the following character afterwards has special meaning.
Do you have to define that meaning for that letter, or does that the computer already already recognized
The
it as.
computer already knows about it. The computer already knows.
Okay.
These \n, \t, \a, on most languages, C, Java, they're the same.
Okay.
They're the same. So these are like predefined. The language knows about them. And notice that it's in the quotes. Endl is outside. This is inside.
Is there kind of like a standard? So, like in a lot of languages, you can do things a couple different ways. Would you use endl more often than /n, \n, or is there any kind of?
I use because I have not seen in Java, since my core language, I use \n, and I use \n a lot more because it's less to type. I'm sorry, programmers use shortcuts. \n is quicker than typing endl. But I do not have a preference if you use it or mix it up. No, because the end user does not know the difference. However, when it comes to your standard that you submit your code, please be consistent. Because when you see someone write those NL and \n interchangeably, it looks not professional, if it makes sense, if that word. Be consistent in the way you do things. When you start formatting, few things you use interchangeably, then you're becoming inconsistent. And sometimes I always say that consistency is a hobgoblin of the small minds, but a lot of companies I work with, they are consistent on being inconsistent. And that's not necessarily just with formatting, that's just how they code the framework, and it becomes a nightmare because you're trying to say which way is the best. I see that A here, B somewhere else. What does the company, what does the architecture demand? And no one can answer it. But since this is simple for just seeing formatting of the output in this class, I don't care. But if you're going to go forward in developing, be consistent. If you're going to use NL, use NL. But sometimes when you look at, before you start coding, look at what the code's already there formatting style and use that. That's gives you a professional thing because you usually have code reviews, and if you become inconsistent, they might ask you to redo it. So, any other questions on that? Just be consistent on which one you want to do. Inserts the pound include directive inserts the contents of another file into the program. That's why it comes back after you get the source code, the preprocessor, you get the modified, because it inserts the contents of another file into the program. This is a preprocessor directive, not part of the C++ languages. The pound include lines is not seen by the compiler. Do not place a semicolon at the end of that line. Remember, the preprocessor directives are not part of the C++ library, so you have to include them in. Now we're getting to this programmer defined identifiers, aka variable. A variable is a storage location in memory. Like we mentioned before, when you load your program into memory, each variable gets assigned a unique address. And from there, we need to know the data type. So to declare a variable, you need to know the data type, which is an int in this case, and the name. And we'll cover naming conventions later on. So this has a name and a data type of int and must be defined before it can be used. You must define your variables before you use them. Unlike JavaScript and unlike other languages, JavaScript is a little bit different. It hoists all the variables to the top. The way C and C++ compiler are, including Java, you must define it before you use it. It can be defined the line before, the line on, but you must define it before you actually use it. So for right here in this example, this int num, this defines a data type number. Now this assigns 5 to it. Remember this equal sign right here, it's not an equality check, but it's an assignment. It takes 5 and assigns it to inside number, and so then you can display it. Simple. Any questions? A literal is a value that is written into the program code. Like these string literals that you see, hello there, 12. In this case, you see this number 5. This is a string literal right here. This 5 is an int literal. It's written in the code. Anything that you see written in the code is treated as a literal. Here's this example of 20. String literals.
Wait, so if you go back to that photo, why would you define apples over just doing like the same C outline that says 20 apples type of thing?
Say that one more time. Repeat the question.
So what would force you to define a variable here instead of just potentially typing like 20 apples as a C outline or including it there?
So instead of saying today we sold and keep this and putting 20 right here.
Yeah,
Well,
yeah, just making it say that is like 1 or 2 lines.
Well, in this case, later on, this could be a bad example, but most of the time for this apples and so forth, you would read that in from the user and then display whatever the user enters here. So this thing is going to be kind of dynamic, but in this case, it's static. So you could do today we sold, and you can put the number 20 in here. That's fine. But eventually,
and then user entry.
Yes, but eventually you want to display dynamic text. The user enters something else, but that's why they're saying this is the way you would display your variable. Make sense?
Yeah, that makes sense.
Okay. An identifier is a programmer-defined name for some part of a program, variables, functions, and etc. So you can later on define functions and names and identifiers for parts of code, and we'll go into that more as we go throughout this chapter. But that's just to identify certain parts of the program. Here is a chart of the C++ keywords. This is not all of them. We won't cover all of them in this course, well, in this semester, but we'll cover some of them. And you'll learn some other ones as we move along. But as you said, these keywords are all lowercase and they have special meaning, and they cannot use for anything else but for what they are supposed to be used for. And we'll go into some of these as we move forward. A variable name should be represent the purpose of the variable. For example, items ordered. I used to work in a pharmacy. We would name a variable RX, or if it's a transaction, TX. Whatever you want, give meaning to your variable. Just don't put integer X or integer Y. Give meaning to it, like we saw before, apples, the count of apples. Because when you read your code, you want to be able to understand, when you look at that variable, what's the purpose of it. The rules for identifying using identifiers, function names, or variables is right here. They missed one, but what's the first one should be used? The first one that should be used is you cannot use any keywords, aka reserved words, period. But to name it, the first character of an identifier must be an alpha character or an underscore. After that, it can be alphanumeric, an underscore, no special characters, and uppercase and lowercase are distinct.
When would you need to use the underscore, or when is it? What have people decided that would be the best use to have the underscore be the first character for a variable versus just a normal name?
It could be. It's all defined on the rationale of your organization. Most of the time, they do not start with an underscore like functions. But let me see if I can go like this. Open up Word. So they would. I never seen like says variable name here. Variable name, bar name. I never seen things like this. But when you define constant variable name, they will put all these in capital letters. They would use underscore to separate the words, because if you do not use that, the normal way you do it is do camel notation. and you would use first word, first letter, capital, and then first name. This is the way you would see a lot of variables named. The first character is lowercase, and anything else is capital of each word after that. But you do not see underscore at the very beginning. But for constants, since they usually put capitals all the characters, so it denotes when they see that in the code that it's a constant, they would use underscore to separate them. That's where I see most of it. Does that answer your question?
Yeah. Thank you.
Mm-hmm. Let's go back. Play from current slide. So here's some examples of valid and invalid. As you can see, none of these are reserved words. Oh, but I meant to do this too. This is a keyword, but it doesn't stop me from doing this because one of the rules was lowercase and capitals are treated differently. So double, D-U-B-L-E. These are two valid separate variables. Don't be stupid and do it, but it's valid. Just because things are valid doesn't mean you should use it like that. So right here, let's go back, current slide. This is valid because, oops, no reserved words. It doesn't start with a number. It starts with an alpha character or underscore. No special characters, and so forth. You can have underscore in it here. No special characters here is invalid, and so forth. Just remember those rules. And I think one of the questions I've seen on one exam or things I've seen, the max characters that you can have is 31 characters. I think it was something like that. I think I only did it once to infuriate one developer in Java. He goes, "Your variable names are too long." I go, "Comments in the code." I don't have to put a comment because that variable is 25 characters. If you read the variable name, you know what it's doing. So, all right. Now let's start getting more in depth regarding the data types. Integer data types are whole numbers only. Oh, you don't see any decimal places here. Whole numbers. So if you see the number 2 or 3 written on the quiz, those are ints. If you see me doing around 3.0, even though it's the same thing as 3, it's treated as different. And we'll talk about that later on. But before I go back, can anyone tell me how do they get these ranges? Why are those ranges?
That's the amount it can hold.
Do what?
That's the total that goes on the scale from negative to positive.
Well, right here, no. I created a spreadsheet. See if you can see this. So I took an example of this one right here of an int, which is 2 bytes, which is 16 bits, 1s and 0s, right? So as you can see in binary, here's my binary base right here. Can you see this, or it needs to be bigger? Is that better?
Yeah, somebody in the chat said that it was too small.
Too small? Let me see if I don't know if I can blow this up. Let me see. Is that bigger or? Good or bad, indifferent? The screen is
I mean, I think it looks fine.
okay. Thank you. So in this byte, the shortcut has 2 bytes. That means 16 bits. So 0 to 15 is 16 bits. So as you can see, it counts in binary. So here's my range from right here, right here. This most significant. So this way, this range bit goes from this PowerPoint slide. It goes from negative 32,768 to positive range. So if this bit is set and all the rest of them are 0, like right here, it's negative 32,768. The most significant bit is the sign bit. With all these others being set, the range is from 32767 to 3268. So be careful when you do your addition of adding one and overlapping. For example, I have all this range max of 32,767. If I add 1 to it, all these get flipped, and now instead of being 32,768 positive, I get the negative. So be careful with your ranges, but I wanted to show you how these ranges come to be. And so if you do not, like on this example right here, if you do not have a short, if you do not have the unsigned, then from there, you don't have to worry about the sign bit. And so all that ranges go from all the positive. So you don't have to worry about all these negative numbers. But I just wanted you to be aware on how those values come to be, the range.
I see that and I'm listening, but I'm really confused.
On this one right here,
Just like this entire integer data types just looks very confusing.
these, if you go into more on programming concepts, the numbering system that you deal with in programming is binary, hex, octal, and decimal. This is the binary number system, like with 2 to the power of 0 is 1, correct? You remember the powers? So this is the ranges when you go from 2 to the power of 0 is 1. So what I was just trying to say here is, here's your range from that unsigned bit, all this. So for you to calculate from 32767, that's, if you had all these values right here, it's going to be 1 less than 32768, which would be 32767. That's the range of having 16 bytes and the most significant one being the sign. Oops. So this is the way, it might be a little bit over the top for this class, but I just wanted to show you how these come to be. We can go on. If you need more details, we can take it offline and I can explain this more to you later. But this just shows you the range. Where's the PowerPoint slides? Current slide. Just know that int data types can only store whole numbers. Whole. When you define your variable types, you can define them on separate lines. Int width, int length, unsigned int. If they are all the same data type, you can list them all on one line, but you have to follow them by a comma. You don't necessarily have to put a space, but you have to at least have a comma. Here's an example right here. They're defining the variables right here, and then they're initializing them right here. You can do this all on the same line. You can put int checking equals -20 right here. That's no problem. All they're doing right now is defining the variables, then initializing the values, and then using those displays. Any questions on this so far? An integer literal is an integer value that is typed into the code, like these right here. Integer literals are written into the code. To me, read this and take it as a grain of salt because it's kind of stupid. Integer literals are stored in memory as ints by default. Yes, they are. But to store an integer content in a number memory location, put L at the end of it, and this will force it to be stored in long memory. to store an integer constant in a long memory, which is usually no difference because if you look at the chart, I think both of them are 8 bytes. And constants that begin with 0 are base 8. And this is base 16. Once again, if you're not familiar with it, you don't need it for this class. But for those of those going to go into more of the software programming and software engineering, you'll be familiar with it. I just put this for reference. Binary base 2 is everything is either zeros and ones, binary. Octal is base 8. Everyone's familiar with the decimal. That's what we use every day. And then also hexadecimal, right here, is base 16. And this is the one that converts starting with 9, going A, B, C, D, E, F. You will not be required to know these for the quizzes, like how to format it. Just know that binaries are base 2, octals 8, decimal 10, hexadecimal 16. Just know that these numbering patterns are out there. Later on, in more advanced classes, you'll discuss this more in detail. If not, we can take it offline, but I just want to put that out there for you.
Wait, I have a question. So,
On which one? This?
about the else storing integers. You said it's stored as a normal integer, integer literals by default, right? So if you want to make it a long, put in a long memory location, you put that at the end of what value you're setting it to.
Yes, 1, 2, 3. You would say 1, 2, the number, and then put an L at the end.
So what if you want to initiate, but you don't know, you want to make a variable, but you don't know, it's going to be a long memory, you want long memory, but you don't want to set it.
What do you mean you have a long variable that you want to store, but you don't want to set it, correct?
Yes.
So you could just type in, like instead of using that, you could just type in long variable name, right? There's your variable name. I'm not setting anything.
Would I have to put initiate in there? INT?
I don't have to initialize with the value or anything. All this right here is saying, hey, I want to define a variable, and it's going to be type long. Right now it has garbage value in it. I didn't give it any value. But the operating system is going to say, when this loads into RAM, says this program needs to hold 8 bytes for a variable named variable. Does that make sense?
Yes.
Like right here when you mentioned before, right here, they're right here. Look, long diameter. They're not doing anything with it right here. They're just defining my variable so later on I can use it for reference and display. This is what they're saying right here. If you have that variable 1, 2, 3, and you want to store it as a long, that's why I find it stupid. Instead of doing integer x and you want to store this as a long, like this, this is stupid because instead of doing this, you just want to do long. Make it long to begin with. Because the point of it comes back to this. Ints have this range of bytes, 2 bytes, 0 to, but if you're doing long, which I haven't seen too many doing long, they have, look at the range that they go. So if you're going to store an int that has 4 bytes and you're going to try to store this big value into this, you're going to have problems. And we'll have seen that before when it goes, where the compiler says you're going to lose precision because you're trying to store this big number into a 4 bytes when in actuality it should be an 8 bytes.
Okay. One more question. So what's the difference between the int when you say main and then int and initiating a variable?
They're the same. See right here, they have int main right here, int main. They're the same. All that this is saying is at the very end, return 0, which is just an integer, 0. The reason why you want to return a 0 in this case to main is because 0 gives a status back saying, I ended this code successfully. If normally you would send back a non-zero value to a main, usually it errors out as a problem. Like sometimes when I did things in Linux, error 13 would be a permissions error. Something ended, and so I'm passing back something to the calling saying, I ended abruptly. So I'm giving you this numeric code back. So that's why a lot of things when you see int right here, you want to say, hey, I have no problems. I'm going to return 0. So it means that this main, once it ends this last line of code right here, it's going to say to the calling operating system, whoever called me, I'm passing back a 0 saying I exited successfully. And we'll cover that some more later on as we get more in depth.
I have a question.
Yes.
So just so I understand this correctly, where it's saying long diameter and you have the 100,000, if I wanted the number of diameter to equal something higher than that or higher than 4 bits, I would have to name it long diameter?
Most of the time, yes, you could say long, but most of the time I have never seen long. I just seen long.
Okay. That's just in case you have such a big number that it's going to exceed how much it can store in a long integer.
Yes, and watch your compile error messages because sometimes those will not be error messages. And you remember we saw the error messages when I deleted the semicolon, how it was jiggled in red?
Yes.
If you remember that on Wednesday?
Yes.
That's an error message, but some of these error messages, when it's precision-wise, those are sometimes warnings. Warnings means it's an error, but I'm going to allow you to proceed on.
Okay.
So we'll see some of those as we do our labs. So don't get too in-depth right now because you're going to come across these errors later on. Just know that ints right now only store whole numbers, period. And doubles and so forth is going to handle the decimal places. This right here is just saying, by default, integers are stored by default to ints, those literals. However, if I want to force it to go to a longer value to store as a long, I would use this. I don't see this too much because if you're going to define something using a long, define it as a long. Don't use int and try to convert it. And we'll see that as we go through labs. Char is another data type that can only handle a single byte. A single byte. So when you define it and you initialize it, single byte, single quote. So when you store this letter code, letter C, it's going to store in memory 67. Why 67? Can someone surprise me and see if they know why that 67 is? Why didn't it say a C?
Because that's where it's stored.
That's not the address.
It's associated with the letter C, capital letter C, the number.
The capital S game. We handle the American Standard for Information Interchange. You might have heard the term ASCII. That is the formatting on it. Since you have the online book, I don't know what it is. It might be a template if you look for American Standard for Information Interchange, ASCII. There's also Unicode, EPIDEC. There's other standards. So if you look at it in the Google and say American Standard for Information Interchange, you would see that each character on your keyboard is associated a number. So C is associated with the number 67.
So C++ recognizes ASCII and uses that same memory for its same compiler, right?
No, this is just a code that's stored in that address.
Oh, okay.
67 is not an address. This is stored in that address.
Gotcha.
Okay. Character literals must be enclosed in single quotes, as we just mentioned. So character letter right here, you assign it A right here, it's going to display out A here. Now I'm overriding A to put B, and now it's B. That's just an example. A string that we saw before is a string of characters. It can have numbers in it too, but it ends with this null terminating bit. It's not accounted for in size, but it's there. You don't have to put it in. It's there. Like hello right here. In memory, it's going to have HELLO followed by the null terminating bit. But this is a string of characters, so you need to have the double quotes. Unlike char, it's single byte, single quote. This is a string, which is a series of characters, so then it is going to use the double quotes. So you can use a string. What's my?
May I ask, what's the point of doing a single character at all versus just doing like a character string? Like, what's the point of having a char?
Size and how they want to handle it. Because you can have a string right here and it says test right here, and you can have a single character in there. But in memory, it's actually going to store C and the null terminating bit. 2 bytes. Char test2 is a single quote, and that's just going to be stored in memory as a single byte, 1 byte. So this takes up more memory. Strings are not part of the C++ library. This is what we call primitive data type. It is part of the language. So it all depends on how you want to handle it. Strings sometimes are handled differently than characters, so it all depends on what you use. Can you use them interchangeably? Yes, you might be able to, but behind the scenes, they are different. Make sense?
Yeah, that makes more sense.
You can, it's all depends on how you want to handle it, but yes, they are treated differently. This is kind of, how can I say it? With the new version of C++ that I've seen, I think this is outdated. The C++ string, you must include the preprocessor directive string. So for any quizzes and exams and for your writing programs, you need to include string. So to define a string type, you use string and first name. The previous version of the C++, you could have used string and without using the preprocessor directive, and you would have no problem using it until you tried to display or do anything with it. Cin in it, cout the variable, then it would have problems. But later on, this newer version that they upgraded to, it seemed like this is dated because you can use it without it, but we can test that in lab. But for us to use string, we must include this preprocessor directive. So now you have 2 preprocessors that you need, that you're aware about. iOS stream, and now you have string. This is the way you define a string if you want to initialize it. And this is going to come back and bite you again when you do CN on how to read in strings. So be cautious on this string type coming up. We'll do that in Chapter 3. String movie type, movie title, Wheels of Fury, and from right here, it's displaying. Same thing what you do in define variables right here. You're just setting it and you're displaying it. Floating points. Unlike ints, floating points handle decimal places. You have float, you have double, you have long double. The only difference is the precision on how big you can store the variable. Most of the time, everyone uses double. In the real world, I have seen double. I hardly ever see float. So the stores in similar to, by default, they're stored in scientific notation, and we'll talk about that in Chapter 3. We'll talk about formatting. Here it is, single precision float, 4 bytes. This is the range. Double, 8, this range. So I don't know why this could be a typo in the slide. I don't see the difference between why having a long double precision when it's just both 8 bytes. I think, as with later on we talk about unions, I think they started using floats and chars back in the time when memory was a prime. So you would always want to use the smallest amount of memory that you needed, because each one of these things that you on, it adds a memory location in RAM. So you have a lot of doubles, it can eat up a lot of memory. So they would use floats if they didn't need this level of precision. But since memory has been cheap, a lot of people just use just double. And you can display this in scientific notation right here by default. Sometimes when you talk about chapter 3 with formatting, if the number gets big, it's going to display in scientific notation. If it's hit and miss, sometimes it'll display in normal notation, like this. Current slide. Like this. But when the number gets big, it'll automatically by default display like this, and we'll talk about that in chapter 3 when you talk about more formatting. There are defaults sorted to double. Here's the example. Distance. Here's the scientific notation that they put in. Mass right here, and it's displayed. The other type is data type Boolean. It represents true or false, ones and zeros. Like if you do a circuit analysis, 1, the power's on, current's going through, 0, the switch is off, no current. I'm going to say this right now so I can beat it in your head right now when you start talking about chapter 4. All in C and C++ that I know of, all zeros are false. Any non-zero, that means 0.012, 1.2, any non-zero is treated as true. And you will see that more in depth in chapter 4 when I assign a numeric to a Boolean. So, represents values of true or false. You will start seeing this when you start doing if statements and looping. So Boolean is set it to true, it goes to 1, and false, it's 0. But any non-zero is treated as true, and we'll see that coming up. If you do not know the size of a data type, you can use a function called the size of. The size of will return the number of bytes needed to store that data type. You can pass it in a double, the data type, double, the keyword double, or you can pass it in the name of the variable, and it will tell you how many bytes it needs to store that value. So if you don't have a book to look it up, you can simply do a size of, and it's going to tell you. Assignment statement uses the assignment operator to store a value in a variable. This statement assigns the value 12 to the item. You cannot flip it. Sometimes you see in the old compilers, this would be called the L value, and this would be called the R value, left side, right side. So you cannot assign items to 12. It's the other way around. This will not work. Oh, my mouse is very sensitive, so I'll keep on hitting it. To initialize a variable means to assign a value to it. For right here, we're defining our variable and assigning it on the same line. That is valid. Same here, int number right here. Remember you said you could list all these different variables on the same line followed by a comma, only if they have the same data type. So you can initialize some and not initialize some. Any questions? For some of it doesn't matter which way? Nope. Here's an example that they did int months, days and then just display it. This is another slide you can read and then toss it off. C++ introduced an alternative way to define variables using the auto keyword and initialize value. Here's an example. Auto, amount, and then assigning 100. So by now, memory hit, performance thing, it might be small, but if you're doing it 1,000 times, coming from working on the projects where performance was a key, where you have to get things executed in milliseconds at a time, stuff like this, even though it might be small, will be a ding. Because if you know what your data type is, then use the correct data type. Do not make the operating system automatically detect what it is. Most part, it could be 99% of the time correct, but it's also a processor time because the system has to determine it. Does that make sense? If you know your data type, use your data type, but in this case, it's another ding because now the operating system has to determine which data type it is. And then when you're writing your code, it could handle quirky. Is it a string or is it a numeric? So if you know your data type, use it. Scope is going to be very key. The scope of a variable is the part of the program in which the variable can be accessed. A variable cannot be used before it's defined. For example, this right here, it's defined after it's used. So the compiler is going to give you a warning message saying, hey, I don't understand what is value because you defined it afterwards. And later on, we'll come up with block scope 2 to say the life of this variable is only the life within this function. So we're going to cover scope multiple times. But make sure whatever time you use it, you define it before you use it. Any questions on scope? Only from the point where it's defined, it can be used. And I'm going to change that scope up later on when you cover chapters 4 and 5 and 6 and 7. Arithmetic operators are used for performing numeric calculations. C++ has unary operations, binary, tertiary operators. This right here is a unary operator. We'll talk about more unary operators when you use increment and decrement. But there are unary operators, and even including knots. We'll cover those in further chapters. Binary operators require two operands, like 13 minus 7. This is subtraction. And a tertiary one we'll cover in chapter 4, which is this. And we'll go that in more details. But this is nothing but an if statement, if else statement. But we'll cover that in chapter 4. I'm not going to cover all these operators because most of you already know simple math. But when it comes to the data types, be very cautious on what they are. If you see these at 7 and not 7.0, they are treated as integers. So be cautious on some of them. When you do the calculations, we'll talk about type coercion, where one type gets upgraded to the next. So these are simple. 7 plus 3 is 10, subtraction. But notice right here, when you do 7 divided by 3, that's technically like 2.5. But since they're both ints, remember, ints do not do decimal places. So even if we didn't have this equal to answer right here, 7 divided by 3, since they're both ints, is only going to return the whole number value. Does that make sense? Class, everyone make sense on that one?
Yeah.
This right here is a modulus. It gives back the remainder of integer division. Let me be very clear on that. Remainder of integer division. Because if you have a decimal place, you can't get a remainder. You can only get a remainder when you do whole numbers. So 7 divided by 3 goes in 2 times with 1 remaining. And this is just the program that we showed earlier regarding wages. So I'll let you go over that. This is a good reason why right here, calculate the regular wages. Notice the comments above it, giving meaning to what the statement does. Declare variable names, so you do not have to worry, well, what is X and Y? This tells you base rate times regular hours, and so forth. Here's what I wanted to get pointed out to you. 13 divided by 5 in integer division is 2. 91 divided by 7 displays 13. However, 13 divided by 5.0, now we get 2.6. 91 divided by 7, now we're getting the decimal. When you do calculations, it's always going to migrate to the highest data type 1. And there's a chart in an upcoming slide that shows you the hierarchy of different data types. Int's like the lowest, then it goes float, then it goes double. But once you see one of these as being a double right here, the other one has to be upgraded to a double as well to do the calculation. When it comes to C and C++, they must be the same data type. So this one, when it comes to calculation, is going to be coerced to be a double to give you 2.6. So remember, when it comes to quick questions, if you see both whole numbers, it's only going to be treated as int. If one of them is a double and you see a decimal mark right here, and this is an int, it's going to give you the decimal value. Right here.
So you're saying even if we don't define it as double and we just put it as 5.0, it'll still display.
Like right here, we didn't define it as 5.0. This is literal written into the code.
Okay.
These are literals. These are literals written right into code. They're not variables or anything. They are written right into the code.
Okay, but once you add the decimal, it's going to display it as the decimal?
Yes, as long as both of them can have decimals, but as long as one of them did, then yes, you're going to get the decimal.
Okay.
If you use a variable, will the 2 variables that you use be changed into, let's say one of them is a double, the other one will be changed?
If you have int x divided by double y, the calculation of the 2 would be a double, but the int itself, it will be unchanged. Does that make sense?
Yes. Okay.
Okay, and we'll get more practice with it later on, so don't be over mind. Right here, the modulus right here, 13 modulus 5 gives you 3, but it's going to give you an error because remember I said it gives you a remainder of integer division. So it's going to be caught right here because this is not an integer. Comments we talked about are used for documenting purposes, intended for persons reading the source code. Any kinds of things that you would want to do. Indicate the purpose of the program, describe the use of variables, anything you want. Insult a person. They are ignored by the compiler. You can put this single line comments right here. You can nest them in the code itself, but make sure it's after the semicolon, but you can nest it inside the code because it gets ignored. This right here is what we call a double line comment. Make sure that when you create this opening one, you also create the closing one. You can also use the multi-line comment as a single line, so there's no problem. Name constants. variables whose content cannot change during the program execution, used for representing constant values. So which means if you cannot change it, you must initialize it on the same line that you defined it. If you do it any other way, you have an error. Because I'm saying this constant double tax rate, all capitals, that's why I said it's usually the standard that you see when things are capital, that means they're constant. You must define it, you must give it value, same line that you define it. Here's just an example right here using constants. You can use constants in calculations, and there's no problem. They just cannot change. The program style, goes with those indents that we talked about last class period. The visual organization of the source code includes the use of spaces, tabs, and blank lines. It does not affect the syntax of the program. It actually affects readability. And you want your code to actually be really nicely formatted. Any questions on that one?
So you were talking about the auto function that has been added. Would it make sense to use it for something like a user input, which you wouldn't know, and then you could use it to check?
No, because technically if you're going to be prompting a user for input, you should know the data type that you want to get back. And on some things, the same thing when you talk about a UI form. On some things that must be numeric, guess what? On some of the UI form, there's constraint violations right there that if you ever tried to, if they did a well-job form, if they typed a numeric value in, if they typed the character in numeric field only, guess what? That form should hiccup that back, right? And highlight it. So when you do text-based programming and you require them to enter, let's say, a numeric value, you're expected a numeric value back. So do not use auto because you're telling them, I need to use a numeric value. If you don't give me a numeric value, I'm going to give you an error message back.
Would that break the program, or if let's say they gave me a character instead of an integer?
No, we'll cover that in chapter 10 where he talked about input says, hey, I want a numeric, and there's a function called isAlpha, is numeric. And that will pass back true or false. And we're going to do a lab on that, testing character input from the user to make sure it's correct. And we'll do that in class. That's in chapter 10. We do some of the data validations. Most of the time, if you know the input that you request, you want to make sure you get that data type. You don't want to use an auto keyword to say, okay, system, auto detect for me. Well, they entered a character and I'm expecting a numeric. That's going to make me potentially have a logic problem, correct? Because now the operating system is going to auto detect as a character and I'm expecting a numeric. Any other questions? For those that have more questions, we can open up Visual Studio and we can create one and start practicing with this.
Oh, hello, can you hear me?
Yeah, I can hear you.
Okay, so is the quiz chapter 2, is it next week on Wednesday?
Yes.
And
that's, go ahead.
What's going on this Wednesday?
This going Wednesday. I think we're just going to review and do in-lab. So every time we finish a chapter, let's say right here, we lectured all this day. This is the way the normal format's going to be. We covered the entire chapter 2 PowerPoint slide, chapter 2. So now on Wednesday, I'm going to ask those questions to you regarding those random questions that are going to come up from chapter 2. And then we're going to also have a practice lab, which means we're going to open up Visual Studio. We might take a program from, well, according to Prevail's online things, it doesn't have example programming assignments in the back, but I can pull one up from my back and back of the book and say, okay, we're going to write this program together in class. Let's do it. We're going to open Visual Studio. Here's your programming assignment. That's not for grade, but we're going to do it together to do the steps of declaring variables, grabbing input from the user, doing the calculation, displaying that, for you to get practice with what you need to do before your Lab 1 is actually assigned. These is what I grade. These Lab 1 assignments, Lab 2 that actually do. These practice ones are just for our in-class where we take an example program and we're going to enhance it. And we're going to make it more and more complex each time we do it. So once we get to Chapter 3, we're going to use the same program and we're going to enhance it to cover, let's say, if statements. The next time we're going to do it again, we're going to use looping. The next set, we're going to use functions. We're going to enhance it to cover the concepts that we learned about in that chapter. Does that make sense?
All right. Yep. Makes sense.
So, like right here, we covered Chapter 1, so I asked you some questions. Oh no, I'm sorry, we did here. We reviewed Chapter 1. Now we finished Chapter 2. Everyone now is responsible for all information regarding Chapter 2. So come Wednesday, when I start pulling up those questions again, you should know those questions that I will ask. And then this might be in different order. We might do the practice lab first and then do the review. But this is what we're going to do on Wednesday. Do a practice lab and then review. You have your day off, and then we're going to have a quiz. It's the same concept. See, on Wednesday the following week, we do Chapter 3. When you come back after we do quiz, we do a practice program, review, and then you have a quiz again. So you kind of have a quiz every week, but you're going to cover the entire lecture. You're going to have an in-lab, and you're also going to have a review. Any other questions or concerns?
Yeah, going back to the string. So do you have to add or include string if you're including IOStream? Because I'm confused on that. Because I mean, you could still write out strings with IOStream, correct?
Yeah. So let me. So which slide was it when regarding strings?
What?
Let's see.
Give me 1 sec. 31.
Back. 31.
Or I'm sorry, not 31. 21.
Are you talking about strings like right here?
Yeah, when you were talking about the hashtag include string.
Right here.
Yes. So what? I mean, what's the difference between that and the IOStream?
What IOStream? You mean IOStream?
Yes.
Like IOStream?
Yeah.
Okay.
IOStream.
Stream is used for the C in and C out.
Okay. But
Are you talking about this right here? IOStream.
Yeah.
You said IOStream, so I misheard you.
Yeah, that's what I'm talking about.
This is include this. Remember we talked about this include IOStream and using namespace allows you to use the C out and C in
Okay.
to display it to the screen. That string is a data type called string, so you can use string here.
So you couldn't use that if you were just using IOStream?
This, I guess I'm getting lost in the question. The IOStream is used for C in, C out for just reading in variables and reading out. String is to be able to handle these type of data types, string. So if you didn't have this right here, the compiler wouldn't know what this word is.
Okay.
Let me turn up Visual Studio. Any other questions? So I'm going to stop the recording.